Today we're just going to answer the question, what is pressure? So what really is pressure? So pressure is basically the force over area. So let's say we have a blank of sheet here and then we just apply the force. So how do we calculate the area? So the area, pressure, I mean the pressure, how do we calculate the pressure? So the pressure is just basically force over area. So this means that pressure is directly proportional to force, meaning if the force increase, the pressure will also increase. And pressure is inversely proportional to its area. So meaning if you increase the area, the force will decrease. I mean, decrease, yeah, that should be decrease. Okay, now. So pressure can also be defined as in fluid. Let's say it's in fluid. So pressure in fluid is going to be the density of the fluid. So rho multiplied by the gravitational, the gravity multiplied its depth. So let's write this. So in fluid, this is the equation where P, so that P is going to be the rho, P is the density, the capital P is going to be the pressure, G is the gravity, gravitational acceleration, or just 9.8, and H is basically the depth or height of that fluid. Okay, now, so to illustrate it, let's solve this problem. Let's say we do have an object which is rectangular and we do have its length and width. It's going to be 4 meters and 2 meters. So we all know that pressure is going to be force over area. So force, so the only force that is acting to this thing is just mass and its acceleration, which can be mass times gravity, or weight is equals to mass times gravity. So we can replace F as mass times gravity. And let's leave the area there. And then the mass, we all know it's going to be 5 kilogram. And our gravitational acceleration on Earth, it's 9.8 approximated. And we have area, which is 2 times 4. So we do not need height because it's going to be the volume. And also it is not even. So we have Newton over square meter. So this thing can be also written as pascals, PA. So this is the standard measure for pressure, the unit of pressure, it's pascals. If you have Newton divided by square meter. So the answer here is going to be 6.125 Pascal. So let's keep getting the idea of what is pressure. So the standard pressure of in sea level is going to be 1 atmospheric pressure. So ATM is just the acronym for atmospheric pressure. So the boiling point here is going to be 100 degrees Celsius. But if we do increase in elevation, the pressure is going to be decreased. It will become 0.6. Let's say that's 0.6 atmospheric pressure. And the boiling point of water here is going to decrease. So it is easier to boil water in high elevation rather than in standard elevation. So if we're going through down this hill, so the pressure will increase, causing the boiling point of water to also increase. So this is how elevation and pressure relates to each other. So the higher your elevation, that is going to cause you to have a lower pressure. But if you are have low in elevation, then that means you have more pressure. That's why in cave there's more pressure, or in depth of the water there's more pressure because its elevation is going down. And also the boiling point of water changes. So how do that happen? So it is caused by the number of molecules that is on that specific point. So we all know that in high elevation it's going to be low pressure, and in lower elevation that's going to be high in pressure. So as the elevation increase, the number of molecules decrease. Also the pressure um, decrease. As we can see here, we just put circles for. Now let's get a review from the air molecules. So we all know that lighter molecules, they just go up, and the heavier molecules just go down because of the different in their density, right? So let's name these things. So the helium here is just on the top. It will basically the first one to go on the roof. And H2O is going to be second because it is 18 grams per mole. And this is also dependent on the density of the air here. But let's just say it's completely random. It's around 30 grams per mole. So oxygen is 32 grams per mole. So it's going to be the third one. Argon is going to be 40 grams per mole. And carbon dioxide, which has the greatest molar mass, meaning it is less. It is the one on the lowest point of this container. So lighter molecules, they tends to go up because they are lighter. So we're going to think of, if you're touching helium right now, you're not touching helium. You're probably touching some carbon dioxide molecules, nitrogen molecules, or oxygen molecules, or argon gas. But you can't see them. Okay, so heavier molecules, they tends to go down. Now, as a review for how do hot air balloon works, it just depends on that its density, the difference in their density. So we all know that hot air molecules, they just tends to go up. So if you do put heat on this balloon, it will be fulfilled with hot air molecules, which causes it to rises up. And then cold molecules, cold air, they just goes to sink, and also increasing the flight of the hot air balloon. And just basically for this video, that is pressure. It is basically force over area, and that's it.